This conference will now be recorded.
Good morning to all. Today our topic is diode compensation. So yesterday we have completed voltage divider bias or self bias. So in that we have R1, R2, RC, RE, two coupling capacitors, one transistor. In voltage divider bias, stability is equal to 1. But if temperature suddenly rising, again dropped across RE, voltage will be increased. At that time, VBE going into the decrease. Each 1 degree Celsius, 2.43 millivolts decreasing. Whenever input voltage is decreasing, IB, base current, automatically decrease. So output current every time depending on the input current. So again output current will be decreased with the effect of temperature. That's why diode compensation circuit, how it is work, I will explain. Are you ready? So I am draw the circuit, diode compensation. Sir, మళ్ళీ పెన్ సెలెక్ట్ చేయాలి. ఇదే Okay. Okay. Diode compensation. Okay. Same circuit diagram. Transistor, emitter resistor, here collector resistor, and here R1, here diode. Anode connected to base, here cathode connected to ground. So VCC, you can write here R2 or R1. I am writing R1, here diode. So input with the coupling, input voltage VI, output from collector. So V0, here note down RC, R1, RB. This is ground. Now load connected to output coupling capacitor. This is RL, load resistance. Output across the RL. Here input in between base to ground. So positive connected to base, negative connected to ground. Here output also positive collector, negative ground. Now, whenever output current with effect of temperature, output current increasing, at the same time, the maximum current flowing through the emitter. So here VBE will be decreased. In that condition, your input diode going into the on state. So whenever diode going into the on, here VBE and VBE from transistor emitter junction, JE voltage with effect of temperature VB increase. At the same time, what happened? This current, diode current conducted by the diode, means diode going into the on state. You know very well, whenever diode going into the on state, across the diode maintained 0.7 volts, nothing but knee volt. So if voltage decreasing in VB, at the same time diode going into the on state, it maintained 0.7 voltage, same current flowing through the emitter, means same voltage developed across the VBE, input voltage. So input voltage more than 0.7, input current is constant. So whenever IB is constant, IC is constant. So then beta is equal IC by IB. So your collector current constant, input base current constant. So current gain every time constant. So this is the diode compensation. If any without reverse saturation current, if temperature is increasing, automatically again the reverse saturation current increasing. That purpose we have to connect here one capacitor, that is called bypass capacitor. Positive connected to the emitter terminal, negative connected to the ground. So if suddenly current increasing, here dropped across the RE also increasing, VBE decrease. So that is the disadvantage. That's why we have connected one capacitor. Capacitor function XL reactance is equal 1 by 2 pi FC. 2 pi FC. So reactance of capacitance inversely proportional to the frequency. If frequency is high, capacitor acts as a short circuit. Okay. So capacitor is called AC component, AC harmonic component. So it allows only AC signals opposition to the DC signals. So total input AC current flowing through the CE is called bypass capacitor. Drop across the RE automatically decrease. So output current is constant. And without bypass capacitor, output voltage will be decreased. Means voltage gain will be decreased. So with bypass capacitor, output voltage suddenly increase because dropped across the RE 0. That's why output voltage automatically increase. This is the diode compensation circuit. So third unit is completed. First unit, second, third, all three units completed. Have you any doubts? Any topic? Yes? No one responding?
Sir,
Tell me more.
why we using another capacitor, sir?
Very good question. Okay. See, voltage divider bias. I am drawing voltage divider bias. I will explain once again each and every resistor as well as capacitor. This is our original voltage divider bias R1, R2, RC, RE. Here output coupling capacitor, here input coupling capacitor. Input voltage, output voltage. So this circuit first, without any input signal, we have to find stability. Understood? Catch my point. This voltage divider bias, all biases, fixed bias, collector to base feedback, emitter resistor bias, voltage divider bias, all are we have done without input signal. We have find out stability factor. In first one, fixed bias, stability is more than 1, means almost all 60, because beta plus 1, right? Again, collector to base feedback, stability beta plus 1 into, again here change of IB, RC by RC plus RB. Again emitter resistor also same. Only voltage divider bias, here stability is equal to 1. So this is a very important point. But whenever input signal is connected to the voltage divider bias, this input which one? AC signal. Example I am taking here 20 millivolts. AC or DC? 20 millivolts. AC signal, sinusoidal signal. Example our speech signal. What I am said amplifier? Microphone input. Here amplifier circuit. After amplifier, we have connected to loudspeaker. Example our DJ or our auditorium amplifier. So here microphone nothing but low resistance. A speech signal, very weak signals. These all signals in millivolts only. Here loudspeaker, voltage in volts, more than 10 volts. More than 10 volts. See here 20 millivolts convert to 10 or 20 volts. Means 10 power of 3 strength is increased. That is done by transistor. So whenever input AC signal connected to the input coupling capacitor, here what happened? Input connected to base. So base to emitter junction going into the forward bias. Understood? Same current flowing through the RE. Same current flowing through the RE, emitter resistor. So AC current dropped across the RE. resistor act as a DC component. It allows it allows DC. So transistor activation done by DC supply. This is very, very important. Transistor activation. Transistor activation done by DC supply. That is VCC. Only activation. Just example, our college bus starting from LB Nagar to BIT. So college bus running done by the diesel, nothing but fuel. Here transistor activation done by DC supply. This is only for activation purpose. But transistor amplifier means amplified weak signals converted to large strength of signal done by the transistor. That is AC signal. Understood? So whenever AC signal flowing through the emitter, here emitter connected to resistor, but this resistor is very, very important because of stability. Transistor stabilization done by RE. This value in between 500 ohms to 1 kilo ohm. This is the fix. So if less than 500 or more than 1K, operating point will be changed. It's going into the saturation side or it's going into the cutoff. So that activation done by DC supply, that line is called DC load line. DC load line. So whenever input AC signal is applied, total AC current flowing through the RE. So maximum current dropped across RE. So output voltage as well as current decrease, because here input current totally dropped across the RE. That's why we want to connect one capacitor, that is called bypass capacitor. Here positive, negative. Now total AC signal flowing through the bypass capacitor, here dropped across the RE will be decreased. At the same time, output voltage increasing and output current increase. This is AC current, this is the DC current. So DC is less, AC is the maximum. So here DC load line, AC load line, both are intersection. This point is called Q-cent point. Q-cent nothing but operating point. Understood? So compulsory bypass capacitor we want to use. I will show in practical effect of bypass capacitor. Okay. Next, any doubt? Anyone more, please? Simple doubt also, please ask me. I will give clarification. Anyone? Don't feel whatever you question, ask me. Otherwise, I will ask candidate to candidate questions. Before that, please clarify your doubts. Total 3 units. Rule number 1. Please respond. Rule number 1. Six absent. Rule number 9. మీరు ఇలా సైలెంట్గా ఉంటే ఎలా వస్తుందండి సబ్జెక్ట్? Rule number 2. Rule number 2.
Yes, sir.
Yeah, my doubt. Simple question. Why we want to construct active components?
So once repeat the question, sir.
Why we are using active components? మీరు అందరూ సబ్జెక్ట్ వచ్చినట్టుగా ఉంటుంది, బట్ ఇన్ వైవా క్వశ్చన్ పర్సన్ టు పర్సన్ దే ఆర్ ఆస్కింగ్ డిఫరెంట్ వే, but we want to say answer.
To amplify the signal, we are using active components.
1 minute. 6, 7, 8 option. 6, 7, 8 option. Tell me once again, please.
To amplify the signal, we are using active components.
Amplify the signal we are using. Okay, but main reason why we want to construct amplifier. Okay. Yes, here all components we have applications. I am not asking about application. What is the first goal of our active components?
To control the flow of the current.
Yes, right answer. But actually, I will give some clue. We have 3 type of materials, right? So in 3 type materials, insulator, conductor. Here insulator, every time it didn't conduct. High temperature, low temperature, whatever. In conductors, every time it's ready to conduct the charge. Okay. But we have 30 volts, but we want to design low power. Our input voltage is how much? 230 volts, Indian standard, 50 hertz. But we want to save power. How? VLSI, very large scale integrated circuit. These all are working microprocessor, microcontroller, all are working with 5 volts only. That's purpose, low power purpose. We want to construct active components. You know, before 1937, our transistor constructed by vacuum tubes. Each and every vacuum tube working with high voltage. How much? More than 10,000 volts. Even though your mobile battery voltage is equal to how much? 3.8 volts. But you have a lot of application with 5 volts. You have done 24 hours working your mobile. How it is possible? Possible, done by the active components. That purpose only we have take semiconductor materials. In that also only silicon, germanium, only two semiconductors we have selected, because silicon forbidden layer, here valence electrons crossing empty energy gap with the help of 1.1 electron volt. That is main reason. Germanium only 0.6 electronics, 0.6 electron volt is enough. That purpose only we have to construct N-type material, P-type material, because if you want to construct any component, we need two different potential materials. That purpose only we have adding impurities. So silicon valence is equal to how much? Only 4 valence electron. So if you want to add less than 4, positive potential. If you add more than 4, negative potential. So with respect to semiconductor valence electrons, 4. So less than means travalent. Travalent means 3 valence electrons. One more pentavalent, 5 valence electrons. So whenever we have adding impurities is called doping. Understood? So one is trivalent, one is pentavalent. If you want to add pentavalent, 1 electron is free. The total material after adding that material potential going into the negative. That's why the material name is called N-type extrinsic semiconductor material. And the pentavalent ready to donate 1 electron. So pentavalent impurities is called donor impurities. Trivalent, it's need 1 more electron. That empty space is called hole. It's ready to accept 1 more electron. So trivalent impurity is called acceptor impurities. Okay. So now acceptor impurities, adding silicon, what happened? It's need 1 more electron. So it has positive potential. It's ready to accept 1 electron. So that material is called P-type material, P-type extrinsic semiconductor. Understood? One is P, one is N. 2 different potential materials adding. See this N-type, P-type adding impurities. The process is called mass action law. Here mass nothing but impurity. Action means doping concentration. Complete process is called mass action law. This is in-depth basics. మీరందరూ డిప్లొమా కంప్లీట్ చేశారు, మీరే నాకు చెప్పాలి. ఓకే, నెక్స్ట్ డౌట్స్? Anyone please respond. Okay ma, 14.
Sir, why we using the stability factor, sir?
why we are using stability factor? Very good question. If stability is more, our current gain, voltage gain going into the decrease. Just example, common collector amplifier. Input voltage, output voltage, both are same, but its application is impedance match. Only impedance match purpose we are using common collector. Same thing happened without stability. Our operating point going into the saturation side or negative side. So I will draw here example. This is output characteristics. This is load line. Example, this is the Q point, operating point. This point A, I am taking here point B. Now I am applying here input signal. All of you observed. Okay. See here, starting which one? 0 to positive side. But output, it shifted 180 degrees phase shift. So this is called faithful amplification. No distortion. Example here, input 20 milli. Here output is 20 volts. Means here peak to peak how much? 20 volts. Here peak to peak 20 milli. 20 milli converted to 20 volts. This is amplification. Your question is why we are using stability? Without stability, with respect to temperature, this operating point will be changed. Example, with temperature IC is increasing, operating point going into the here. If you want applied here sine wave, it transmitted only positive peak, negative peak going into the clipping, where saturation side. This is saturation. Below this called cutoff is here. In middle one active. Operating point every time may operating point every time maintaining in active region only. That purpose we want to stabilize the amplifier circuit. Okay, ma? Doubt clear? Without stability, it's going into the saturation side or it is going into the cutoff region side. Rule number 14.
Yes, sir.
Clear, ma?
Yes, sir.
Next. Any doubt, please share with me. Yes. టకటకా అడిగేయాలండి మీరు. సిల్లీ క్వశ్చన్ అని నేనేం ఫీల్ అవ్వను. నేను కూడా అడిగేవాడిని డిప్లొమాలో. మై డిప్లొమా కంప్లీటెడ్ 1993. My diploma scheme C89 batch. Okay, tell me ma. పోనీ నేను అడిగిన క్వశ్చన్స్ Any 4 applications, 4 diode applications. Tell me. Any 4. See, class లో నుంచి లెఫ్ట్ అవుతున్నారు. నేను నోట్ చేస్తున్నాను రూల్ నెంబర్స్. వినాలి కదా. Any 4 applications. Anyone, please.
Used in processors, mobile processors, computer processors.
No. That is different. All components, diode, transistor, it is silicon, all are using process controllers. Not I am asking that. Just example. Diode used in rectifiers. That is one main advantage. Like that. Application.
Switch.
Yes.
Sir, use it as switch.
Very good. It's act as a switch. So can you explain how to act as a switch? అక్కడే మీరు ఆగిపోవద్దు. Whatever you know, tell me. If any mistakes, I will correct. I will give answer. That is only sharing knowledge.
So it clips the signal, sir.
Clipping signals means if you want removing unwanted signals, like we want to select that portion, I am removing.
We
Good,
can
good,
we can convert AC
next.
signal into DC signal, sir, using a bridge rectifier.
Bridge rectifier. Okay. So diode used in rectifiers. One application. Second application is diode used in clippers. Next.
And phase
Diode used
detector.
in clamper. Very good. Clampers. Next. Diode act as a switch.
Used in radar circuits.
Very good. Radar circuits. Okay.
And gain controller.
Okay, good. Diode compensation. Very good. Very good. Like, see, we have lot of applications. Example, I will show EDC subject paper corrections. Lot of people's written very blind. Yesterday I have corrected some few answer states. Full wave rectifier. First question. He was draw the circuit complete wrong. And he's writing anode, cathode. Only that's only waveforms. Nothing is there. How can you give marks? Total I have corrected 29 papers. Only 2 members passed. That also they got 25 marks. I was even adding 1 mark. Only 26 out of 75. ఇంకెందుకు చదువుకోవాలండి మనం? అది భారమా చదువు అంటే? Knowledge. How to work, application, operation, principles, applications, advantages, disadvantages, precautions. This is knowledge. Engineering, nothing but sharing knowledge. If you want, invite anything. Even though you know, 1 year back, one diploma candidate invited FET. Worldwide popular. He is Indian. No need of MTech, no need of BTech. Knowledge only. So you don't know small things, how to go to core jobs. That's why, even though DLRL, Midani, Bell Company, in defense all companies, requirement 0.6% only, because of our knowledge. Zero. No one going into the defense level. 6 members ask at a time lot of questions. How to face? Even though in our lab, no one say correct answers. So please, whatever you want, ask me any doubt. I will give answers. I don't know. I will go and learn. Then I will explain to you. That is my job. Okay? Tell me. We have a lot of time. So I will ask one small question. You are all are diploma holders, right? I have 12 volts Zener. Okay, understood. I have 12 volts Zener diode and volts transformer 06 transformer 606 transformer. I have 12 volts, 4 diodes. Okay. So here GNR diode using in bridge rectifier. It's act as a rectifier or not? Rectifier, you can explain. Impossible also you can explain. Tell me, ma. Anyone? This is gate question. And the second question, half wave rectifier, input frequency and output frequency. Full wave rectifier, input frequency and output frequency. These 3 questions. Who will give answer?
Zener diode in reverse bias act as an regulator, sir. Like a
I am
diode.
not asking about regulator, rectifier.
Rectifier, sorry.
It's act as a rectifier?
Yes, sir.
How?
In reverse. I mean, in reverse
That
bias, sir.
explanation is important. Okay, you are right answer. Zener diode in this condition, it's act as a rectifier. How to? Okay, now my job. What I am given first? Which Zener? What I am written? Read first.
12
12
volt
volts
Zener
Zener.
diode.
12 volts Zener. If you input voltage more than 12 volts, your Zener diode in reverse bias conducting current. What I am given second point? 606. Here secondary voltage only 6 volts. So here Zener act as a normal PN junction. Understood?
So I thought input voltage would be a 12 volt.
Okay. But I have given here 606. Nothing but center tapped transformer. If you want to use normal also, one is ground, any one point A or point B. So here 6 volts secondary. Our Zener, given Zener, 12 volts. So it's act as a normal PN diode. So it's act as a rectifier. Second question. Half-wave rectifier input frequency means half-wave rectifier. Okay, this is load RL. Here example 12 volts, 50 hertz. This is input of rectifier. What about output? చూడండి మీరు ఇంత సింపుల్ క్వశ్చన్స్ కూడా ఆలోచించట్లేదు. ఇదే కదా మన వేవ్ ఫామ్. ఎస్, frequency definition. Rule number 18. Number of cycles within 1 second.
50 hertz.
50 hertz. So this number of 50 cycles completed. How many cycles here? Not one ma. Here positive. One cycle complete. Negative
Yes.
is ground. Okay, same input output same, right?
Yes, sir.
We don't have here negative connected to ground, but here peak is there. Nothing but frequency. That is called pulsating. So in half-wave rectifier, input frequency equal to output frequency. This is gate question. What about full wave? One more peak is there. Negative also converted to positive. So within 1 cycle here, how many cycles here? 2. Frequency going into the double. Here 100. Only syllabus ఇంత ఉంది సార్, నేను ఇంతే చదువుకున్నాను అనకూడదు, తప్పు అది. We wanted to learn, refer lot of books. Nowadays, all books available in online. This is only first unit. See, total 3 units. First, complete diode. Second, transistor. Third, biasing circuits. Fourth, amplifiers. Fifth, JFET amplifiers, MOSFET construction, working principles. Over your EDC. Very, very less syllabus. Next, any questions?
Any other gate
I
question?
will ask. Yes, tell me.
Any other gate questions?
Gate coaching. Our calling gate coaching, నేను ఒక క్వశ్చన్ అడుగుతాను మిమ్మల్ని. 50 minutes for one class. But in gate coaching, he will continue 5 or 6 hours. How many students is there? More than 200. But everyone ready to go to coaching. మళ్ళీ ఆడేం చెప్తారు మేము చెప్పింది 50 hours single topic, no one listening constantly. But in gate coaching, you are paying amount. చదువుకోవాలని మీ మైండ్ లో ఉండాలి అంతే. వాట్ ఎవర్ మాకేమైనా కోచింగ్లు ఉన్నాయా అప్పుడు? మాకు 1000 ర్యాంక్ వచ్చిన సీట్ రాలేదు. ఈ సెట్ ర్యాంక్ మై సెల్ఫ్ 52 without ఈ సెట్ కోచింగ్. That is depending on ourself only. First, you listen topic and once refer the textbook. You can write your own words. Again, cross-check your syllabus. Means reference book, where you have to skip topics. Then again, you can write. You can practice like 3 times after you are expert in the topic. Like that only, you go and learn lot of things. Okay, interest first. Interest. First day, some difficult. After 1 week, very clear, good. After 1 month, that is your hobby. గవర్నమెంట్ జాబ్స్ అంటారు, ఎందుకు రావండి? మీ ఓన్లీ ఒక ఇండస్ట్రీ క్రియేట్ చేసుకోవచ్చు. యూ కెన్ గివ్ ఎంప్లాయ్మెంట్. ఎవరు ఆపుతున్నారు? మీలో రావాలి. నెక్స్ట్, ఎనీ సబ్జెక్ట్ రిలేటెడ్ క్వశ్చన్స్? సో నెక్స్ట్ క్లాస్ we will do experiments, practicals. So according to our regular classes, 3 units completed. Next we will do all experiments. Okay, actually in regular lab we have completed 12 experiments. You are completed present PN junction, Zener diode, and half wave rectifier, full wave rectifier. Next we will conduct clipping, clamping circuits, then FET characteristics, SCR characteristics, UJT characteristics. Okay, any doubts please share in our class. No problem. We will ask number of questions. He will go to high position. Okay, సైలెంట్ గా క్లాస్ వింటే సబ్జెక్ట్ రాదండి. ప్రతి క్వశ్చన్ ఫైండ్ అవుట్ చేయండి. ఎవ్రీ డౌట్ వీఆర్ రెడీ టు షేర్ యువర్ డౌట్స్. నాట్ ఓన్లీ మై సబ్జెక్ట్, all subjects. Okay, shall I close this meeting? Thank you to all.